Solve the following equations. So as you can see on this slide, there will be two different examples. And I'm going to start with this example on the left. So in order to solve an equation, we need to simplify each side of the equation. And generally what that means is to distribute or multiply any terms that need to be multiplied, and then combine any like terms that may have resulted. So you may notice that there are a couple sets of parentheses in this exercise. So what we will do is determine what is in front of this set of parentheses. So here it's a -1. So I'm going to distribute a -1 to each term here and get 8x minus 2x minus 1. And on the right side of this equation, there's a 3 that I'm going to multiply to the x and the -3 inside. So that will leave me with a 3x minus 9 minus 1. And then we can combine terms together. So these both contain x's, and they're on the same side of the equation, so I can call that 6x, and the -1 is still there. And on the right side of the equation, there's a 3x, but these two terms can be combined. So that will be -10. So 6x minus 1 equals 3x minus 10. Now, I need to get all of the x's on one side of the equation. And it's generally a good idea to move the smaller number of x's. So I can see 6 x's here and 3 x's here. I need to subtract 3 x's to get rid of all of the x's on this side. This turns into 0. And then on the left side, you can subtract 6 minus 3 x's to get 3x. The -1 is still there, and this still equals -10. The final couple steps here, we need to add 1, because now that we have all of the x's on the same side of the equation, there are no x's on the right, they're all on the left. We need to move any constants to the other side, so add 1. That leaves you with a 3x equals 9, -9. And then to get rid of a 3 being multiplied to x, you divide by 3. And that lets you know that x equals -3. Now that this example has been done with some detail, this example is going to be done similarly, but with less speaking here. So we will distribute the 5, and on the right side distribute the 25 to get 20x plus 5x plus 5 equals 25x plus 25 minus 20. So then to combine terms, on the left side the x's can be combined, and that's 25x plus 5. On the right hand side, the 25 minus the 20 can be combined. 25 minus 20 is 5, so this ends up being 25x plus 5. And I can take this one more step. We need to move the x's from one side to the other. So the smaller number of x's, I guess, is 25 x's. So I'm going to subtract 25 x's from both sides of the equation. And that goes to 0, and that goes to 0, and we're just left with 5 equals 5. There are no more x's. So if you run out of x's, or if you cancel out or reduce all of the x's away, you just have to ask yourself, is this true or false? Well, 5 equals 5 is in fact true. So if you have a true statement after eliminating all of the x's, 5 equals 5, for example, your answer is going to be all real numbers. If you reduce away all of the x's and you get a statement that is false, that means your answer is no solution, and you can represent it by this symbol here, the empty set, or you can simply write no solution. But for this example, the answer is all real numbers. Solve the following equations. So again, this example here on the left is going to be done similarly to the last two examples. So what I'm going to do here is distribute this -2 and distribute this -6 on the left. So that leaves me with a -2x minus 14 plus 52 equals 4x minus 6x minus 18. So then just need to combine some terms here. So -14 and 52 and 4x minus 6x on the right side. It leaves you with a -2x minus, oops, I guess it's a plus 38 equals -2x minus 18. So again, we need to move the smaller number of x's from one side to the other. But again, this time the number of x's is the same, -2x's and -2x's. So that means I'm going to add 2x's to make that 0. And that means I have to add 2x's to the right side of the equation as well. So now I'm left with a 38 equals -18. This one's false. That means my answer is no solution, or again, you can write out the words if you'd like. Either one of these works, but if you get something that's false at the end, like 38 equals -18, you can give either of these answers and you'll be correct. In the next example over here on the right, this example is a little bit different because it contains some numbers in the denominator. To make this problem appear a little bit nicer, it would be good if we could get rid of these denominators. And the way to do that is to find an LCD, or least common denominator. And you can find a least common denominator by finding first the largest denominator, which would be 8, and then seeing if you can evenly divide 8 by these denominators. So if I divide 8 by 8, that gives me a whole number. And if I divide 8 by 3, that does not. So 8 is not going to be my least common denominator. So I'm going to cross that one out. And then I'm going to go to the next multiple of 8, which would be 16. I know 16 can be evenly divided by 8, but 16 can't be evenly divided by 3. So 16 is no good. Instead, I'm going to jump over here to 24, the next multiple of 8. And I know 24 can be divided by 8 evenly, and 24 can be divided by 3 evenly. So I have my LCD being 24. Now again, the whole point in finding this LCD is to get rid of these denominators. Everything looks better if it's not a fraction. So let's use the LCD to get rid of those denominators. And to do that, you're going to multiply each term by the LCD. So how this will work is in the first term, I need to just end up multiplying 24 times 5, and that will give me 120. With the second term here, I can actually use this 24 to reduce with the 3 in the denominator. So if you divide 24 by 3, you end up with 8. So what I will write down here ends up being plus, and that comes from right here, plus 8 times whatever's left on the top inside. So 8 times x minus 2. And we're going to do something similar over here. 24 will reduce with the 8 in the denominator. And when you reduce that 24 with the 8, 24 divided by 8 is 3. So I'll take that 3 that's left over and multiply it by what's left inside, which is x plus 3. So now this equation here looks pretty easy to solve now. It's done very similar to this one. So I will put up the rest of the solution here, and you can pause the video to check your work to see if you're doing everything correctly. So here is the rest of the solution, giving you a final answer of x equals negative 19. And I will be silent here so you can pause the video sometime within the next 5 seconds to see if you got it right. Solve the following equations. So this is where we start seeing different types of equations, not necessarily with this example here, but with this one on the right side. So we'll do this one in a moment. I want to go back and do this one here. Again, we only have numbers in the denominator. So it would be really nice if we could get rid of those denominators so that there aren't fractions here that plague us. So we can find an LCD again. And again, you want to start with the largest denominator. So we pick 10, that's the largest number in the bottom. And we just check really quickly, can you divide 10 evenly by 10? Yes. Can you divide 10 evenly by 2? Yes. And can you divide 10 evenly by 5? Yes. So it turns out the LCD here is in fact 10. Now that we have the LCD, multiply each term by 10. Again, we do this step to eliminate all denominators. So when you look at the terms with denominators, the 10 will reduce with those. With this term right here, it's just going to be minus 10 times x. We can't reduce this 10 with anything here. So after we reduce, there will be a 2 times a 3x, because 10 divided by 5 leaves you with a 2, and 3x is what's on the inside, minus 10 times x equals x minus 10 divided by 2 is a 5. 5 times 5 is 25. So over here on the left, 2 times 3x will be 6x minus 10x equals x minus 25. So these can be combined, leaving you with negative 4x equals x minus 25. Move the smaller number of x's. You could move the smaller number of x's, being negative 4 x's. But if you move this x, then all of the x's will be on one side, because this will turn into 0. And this side will be negative 5x equals negative 25. So instead of moving the smaller number of x's, which is negative 4 of those x's, negative numbers are smaller than positive numbers. This is a positive 1. We move this one over to the left, and now all of the x's are on one side, and all of the constants are on the other. So now all you have to do is divide both sides by negative 5, and you have an answer. This reduces to 1, and you're left with x equals 5. And that's that example. Now over here with this example, this feels like we're just going to keep doing this idea. It would be really nice if we could get rid of these denominators. And so you look at the LCD. So this denominator is x minus 1. This denominator is x minus 1. Luckily, they're the same thing. So I want to use that as my LCD. So the LCD here is, in fact, just x minus 1. So great, we found an LCD. Now what? Well, before I get into multiplying each term by the LCD, I want you to notice that there are variables in the denominator. That's what makes this entire equation different than all of the other equations you've seen in this video. This is what we would call a rational equation. And all rational equations all this means is that there are x's, or whatever variable you happen to be dealing with, in a denominator. So since there's an x in the denominator, this means there's a chance that the denominator might equal 0. And if it's one thing you've learned, you're not allowed to divide by 0. So how do we figure out what number makes this denominator 0? Well, all we have to do is take the denominator, in this case x minus 1, and write it out. We do not want x minus 1 to equal 0. You can still solve this for x like you would if this were an equal sign. Say by adding 1 to both sides. That will become 0. And you're left with x cannot equal 1. So this is my restriction. X cannot equal 1. If I substitute 1 in here for x, I get 1 minus 1 and 0 in the bottom. 1 minus 1 is 0. We can't divide by 0. So x cannot equal 1. All right, now that we have the LCD and the restriction, let's go through and multiply everything by x minus 1. Multiply this times x minus 1. Multiply this times x minus 1. The x minus 1's cancel, the x minus 1's cancel, which is nice. And what's left here, there's nothing for this x minus 1 to cancel. Right? There's no over x minus 1 on this 5. So what happens? We're left with 2x on the left equals 5 times x minus 1, because that's what's being multiplied here. 5 times x minus 1 plus 2. Right, the x minus 1 is not here anymore, so we're just left with 2. So this equation, again, looks a lot nicer, a lot easier to solve than this one. All right, so let's do it. Distribute the 5, that gives you 2x equals 5x minus 5 plus 2. And now I will combine these to get 2x equals 5x minus 3. And I'm going to subtract 5 x's similarly to what I did over here with moving this x instead of these negative 4 x's. That way I get all of the x's on the left and all of the constants are already on the right. So this zeroes out and I'm left with negative 3x equals negative 3. And finally, divide by negative 3, divide by negative 3. So I get x equals 1. So you can see again that even after we got rid of the denominators here, we still had a really nice equation to solve that was left over, and we went through and we solved it. So now that we worked all the way down here and got an answer, you need to check. Is what I got a restriction? And in this case, it is a restriction. So if you get an answer at the end of all your work, x equals 1, and it matches a number that it's not allowed to be, this answer is no good. So if you have an answer that's no good, and it's the only answer you have, your only choice for an answer then is no solution. Again, you can use this symbol or write the words no solution. And this is going to be important for the next two examples. Solve the following equations. These examples are also rational equations, and you can notice that they are because there are x's in the denominator. So I'm going to start with this one over here, and I want to go ahead and find the LCD for this. Now again, the LCD is what is needed in order to get rid of all of the denominators. So if I want to get rid of this denominator, I know that I'm going to have an x plus 1 in my LCD. And if I want to get rid of this denominator, I also need to have an x plus 2. And finally, you can see that I have an LCD that's x plus 1 times x plus 2. This entire thing will cancel with this entire denominator. So this is the LCD. X plus 1 times x plus 2. That'll get rid of this x plus 2, this x plus 1, and this x plus 1 times x plus 2. So what do you do here? Same thing we've been doing in the past few examples that require LCDs. We will multiply each term by the LCD. You can see that I've gone ahead and multiplied each term by the LCD. And now I just want to cancel the correct things out, like this x minus 1 here will reduce with this x minus 1 here. The x minus 1 times x minus 2 here will reduce with those. And in this last term, the x plus 2's will cancel out, leaving you with x plus 2 times 2 plus 2x equals 4 times x plus 1. So again, we're back in this realm of an easy equation to solve. And before I go any further, I need to find the restrictions. So what we need to do is we need to look at each individual denominator, mostly just this one x plus 1 and this one x plus 2. So if I set x plus 1 and say it cannot equal 0, that means x cannot equal negative 1. And if I take this other denominator, x plus 2, and say it cannot equal 0, then I also know that x cannot equal negative 2. So there's that. These are the restrictions over here. They will not be labeled. I'm out of space. So just keep that in mind, that these are what we are checking our answers against when we get down here to a final answer. All right, so now we can go ahead and do our distributions and get 2x plus 4 plus 2x equals 4x plus 1. All right, let's see what happens here. Combine this with this. That gives me a 4x plus 4 equals 4x. This should be a 4 plus 4. So again, subtract the x's so you can get them all on one side or the other. So 0, 0. Oh man, I end up with 4 equals 4. Well, this is true. So that means my answer should be all real numbers, right? Well, normally, yes. if we had started with a linear equation, this would be the answer. But we have these restricted values here. So we have an answer that is all real numbers except -1 and -2. Even though we got a true statement, the original equation tells us x cannot equal -1 or -2. So this can be all real numbers except x cannot equal -1 and -2. So with this last example for this video on the left, we know again that we are going to be needing to find an LCD. So I always want to start with my smaller factors here, like 2x plus 3. I know my LCD is going to need that. Just like I also know my LCD will need an x minus 1. But how am I supposed to take care of this thing? What will usually happen, not always, but usually, is that when you use these smaller two denominators, notice no x squareds. This x squared makes this denominator quote end quote bigger. So if you use the smaller two denominators to make up your LCD, it will automatically take care of your larger denominator. So if you take the time to distribute the 2x here to the x, that gives you 2x squared minus 2x if you multiply 2x times -1. So minus 2x plus 3x gives you a plus x. 3 times -1 is -3. So I still want to use this version of the LCD because it'll be easier to reduce the 2x plus 3 and the x minus 1. But if I use this LCD here as well, I already know that this and this are equivalent. So I can reduce this entire thing with this entire thing. So I'm going to pause for a few seconds so you can pause the video and try doing the rest of this one for yourself. And I will make sure the rest of this example shows up here in about 5 more seconds. So here is the rest of the worked out example. So you should get this after you multiply each term by the LCD and cancel things out. Again, when you're up here and you multiply these two times this fraction, that entire factor pair will cancel with this denominator here, leaving you with a 1. So then you can distribute, combine like terms, solve for x and get x equals 3. And way back here from the beginning, the restrictions, as long as you set this to not equal 0 and this to not equal 0, you'll get the restrictions x cannot be -3/2 and 1, and this is neither of those, so fantastic. This is our answer.